Hello and welcome to this RECIST 360 presentation. If you are watching this video, it is assumed you have already used the free online facility and reviewed output. If not, please see video description or comments for details. The online version is a free version of the same tool. But it lacks the full features because it is a simple XLSX Excel file. What I will demonstrate is the tool the RECIST 360 team uses to review your lesion and response data with optimal efficiency. Because most work is performed in the cleaning module, which is also the interface you saw in the online version, let's start here. On display is the patient filter module. It is already pre-filtered from a selection made from an interactive chart we will show at the end of this video. The filter shows a selected site in addition to patients with open issues at this site. There are 2 such patients with open issues, so let's select one. By doing so, all other attributes associated with this patient have just updated. So as you can see, the patient filter itself is a useful tool should data review require a focus such as, for example, an interim analysis based on a specific treatment arm. Now let's display this patient in the cleaning module. Take a look at what's available in the top left of the display. We have patient summary information. Further below, we have keys explaining what the icons mean. These include the study periods of the patient timeline, in addition to understanding the origin of displayed data, whether this is CRF in origin or derived by the program. Lesion information is displayed using respective CRF identification codes. However, using the lesion display toggle switch, we can understand both the lesion location in addition to the scan methods used. There is quite naturally a lot of information displayed to the end user. This information is required for the program to identify data discrepancies, but it doesn't mean the end user has to see all of it. We will see how to hide some of this noise shortly. One of the key features is the graphical visualization of target lesions via a timeline. This follows the patient's journey on the study. Let's scroll through this single patient's timeline. Notice above the graph are various disposition events. These are not essential to assist in any calculations, but it can provide useful context as to what was happening with this patient during the timeline. Now take note of the partial response line. This aids, visually, in determining at which point a patient reaches a partial response. Below the graph we include tables of supportive CRF and derived information throughout the timeline. As we continue to scroll through this patient's timeline, we can now see they've not only had a partial response but have also experienced a new nadir. As such, we now have a new progressive disease line which floats in an appropriate position within the timeline. Now, should the patient continue to experience a new nadir upon a refresh with the latest study data, the PD line will reposition accordingly. This makes it visually easy to establish when or if a patient experiences progressive disease without having to trawl through heavy data listings. Now we quickly scroll through the rest of this timeline to its conclusion. As mentioned, we can adjust the quantity of information on the view. We might do this if we want to only see the programmed findings and user notes. The power of this tool is not only in bringing complex data concepts into an interactive visual, but also the fact the program scans the data for discrepancies. Of course, EDC edit checks and manual data review aim to find data issues too, but this tool finds them automatically and in accordance with published articles. Now let's look at some of the programmed findings. Think of a finding in the same way you would think of a data query in EDC. But this goes a step further. For example, to aid in our review, all findings come with a guideline text. It is also possible to click the automatic finding text to your computer's clipboard to form the basis of an eventual query in the approved data management system. The end user can keep track of their actions and change statuses as needed. It is likely you already have lesion and response data review methods in place. And of course, some may argue this is a duplication of effort. But I am sure you can see, this is far more efficient, less error-prone and without undue duplication in the long term. Other types of findings may not specifically be tied to published articles, such as what is considered an acceptable period between lesion scans and eventual response assessments. This particular finding is one such example where the program can be changed in the settings module based on what the study team feels is an acceptable period. Indeed, such an ability to dynamically change the program shows this is an interdisciplinary tool. Take note in this programmed finding and others like it play a critical role in establishing site performance trends. The end user can also add their own notes. This can be useful to keep track of discussions. Indeed, because these are stored by the program even after being refreshed with new data, the combination of findings and end-user interactions can provide a very powerful permanent data issues log for interims and study locks. This is a massive time saver in the long term. Now let's close down all open issues for patients on this site. This concludes the cleaning module presentation. I presented this first because the content is the same as the free online version of this tool, only it is interactive in the full version our RECIST360 team uses. If you have enough information, feel free to stop watching. If you want to learn more, please stick around. The cleaning filter you saw at the beginning of this video was loaded from an interactive chart. There are several features of the tool that will take a long time to cover, and too long for this video. But we can quickly see how this works. Our cursor is positioned over the site cleaning status graphic, so I will click it. The graphic is interactive with several options. For example, copying and pasting for status update meetings. So how did I know the site we worked on earlier had open issues that needed addressing? I simply clicked the graphic, leading us to the view we had at the beginning of this video. And, now, after the 2 patients were cleaned, we can see the interactive graphic has now updated. The program will help avoid double data review. Let's take a look at how this works. Depending on how early in the study's lifecycle the tool was adopted, it may require an extensive review of all the open findings on the first review cycle. However, on subsequent review cycles only changed or new data results in programmed findings being rerun, with any new findings flagged to the end user. To recap, this eliminates unnecessary double data review just in case something changed for any given patient. This will result in quality data review and not quantity data review, with both speed and automation.